2.3 Day 6, Piecewise Functions Continued. We're still on this section talking about piecewise functions. So there's only two examples in these notes. Start with the first one. We're going to make a little graph here. I know some people are using the graph paper, but a lot of times for little graphs it works better just to make your own sometimes. So I'm going to make some tick marks. I'm going to go up to 5, -4, and then -3, and I marked 2, but I really just went out to 4 here. So let's just make a graph. Hopefully yours is nice and balanced. And so the first piece I'm going to add in here is a line that's at y equals -3, that height, and then it goes from -4 to 2, -2 here on the x-axis. So from -4 to -2 on the x-axis, that's my first piece for my piecewise function. Okay, and my next piece, put a point at -2, -1. That's a closed dot, and then that's a horizontal line all the way over to 2, -1. So again, another horizontal line. This one goes from -2 to 2. And then my third piece here, you recognize that? It's part of a parabola. And that starts at 5, 2. There's a closed dot at 5, 2, and then it's true parabola going off of that. So this is my piecewise function. And so just because I have these three pieces, my first question is, does the graph actually represent a function? So I guess to answer that question, you have to know what it means to be a function. So does the graph actually represent a function? I mean, I can call it a function, but is it truly a function? So algebraically, you know you can't have repeats in the domain, right? That'll fail as far as being a function goes. So graphically, it just has to pass the vertical line test. So really the only two places that come into question as far as the vertical line goes would be these breakpoints here. I know the graph stopped there, and it's open there, closed there, open there. So does this pass the vertical line test? If it does, then it would be a function. So I'll just add a couple dotted lines here just to show. Even if you go a vertical line through these points, technically it still only hits the graph one time, right? It would just hit the graph here. It wouldn't actually hit it here. Over here, yeah, it would hit the graph at that point, but it wouldn't hit this point. So I drew a little vertical line. The answer, yes. Yes, because it passes the vertical line test. So it is a function. And then part B. How about the domain and range for this guy? This one's a little tricky. So for the domain, are there any values that x cannot be? So the lowest x value, it looks like, would be -4. But then are there any values in here that x cannot be on this graph? So for the domain here, in pink, I'll try to do little dotted arrows here to represent it. So I know it starts at -4. But then it's not like you don't have an x value for -2, right? -2 is actually one of the x values. It's included. And I know it breaks here at +2, but that's actually included in the graph up here. So technically, the domain would be -4 all the way to +infinity. Because although there's breaks here, where there's a hole in this part, it's included in this part, right? And at 2 here, where there's a hole here, it's picked up right here, so it actually is included. So all the x values that can go in this graph, -4, and then everything beyond -4 is okay. You can plug -2 in, it goes right there. You can plug +2 in, it goes right there. So what are the x values included? The domain, 4 to infinity. So how about the range? The range is a little bit more difficult. So for the range, y-axis, up and down. What are these points, right? How do you represent those as far as the range goes? So I know that this piece up here, the range for that would be 5 to infinity, right? It starts at 5, then it goes off to infinity. But what about the range for these? It's almost like they don't even have any height. They're just like horizontal lines. So technically, these are just like points. And so as far as the range goes, the y values that this uses. So this piece I know goes from 5 to infinity, right? That's what I do with that dotted arrow. But these, they really don't have, they really don't cover much distance as far as vertical goes. So for the range, this point here, -3, that's actually just part of our range. So that's like a point. I'm going to put it in set notation with curly brackets. -3 is part of the range. See, it doesn't have any. It doesn't have any distance to it. It doesn't have any length. It's just a point. And then here's our next point at -1. Again, no distance to it. Just it really doesn't have a height. It's just there's a point here at -1. So I'm going to put union -1. And then this piece, we know, the third piece, we know that just goes from 5 to infinity. So that idea is kind of new to us. What's the range of this graph? Well, if you just have two horizontal lines, the range is really just a single point. Like that's all the length it would take up is a point from -3, and then a point at -1. And then this piece, yeah, this one goes from 5 to infinity. So this kind of notation is new to us. This kind of idea is new to us. Second and final example, example 2. So we're going to use the definition of absolute value. The definition of absolute value, hopefully remember that from previous notes, to write a piecewise function for g. I'm going to give you g. It's going to be a nice absolute value. So g of x is the absolute value of 4x minus 8. So if you remember the definition of absolute value, we can write this as a piecewise function. And then we're going to graph it. Notice I went out to +4, -4, all the way up to 10. So we can write this as a piecewise function. And that part's pretty simple. You write the positive version of this, 4x minus 8, and then you write the negative version of this. Like if you distributed a negative through there, it would be -4x plus 8. So you get one positive version, you get one negative version. So that part's not bad. Positive guy, distribute the negative through, you got the negative guy. But the question becomes, what's the domain? So actually, if you graph this one, it's going to help us. But how do I even graph this? Okay, well, one method you could do is graph these two lines and see where they cross. They'll make a V. So I'll just say like, you know, maybe it does something like that. Graph those two lines, it makes a V, and then you just erase the lower stuff. Like, oh, nice absolute value. So that's one way you could do it. I'm not saying it's the most efficient way. The other way is this. If you look at this 4x minus 8, this is just the absolute value graph that had a couple transformations to it. But it didn't shift right 8. It didn't shift right 8. How far right did it shift? Well, if you're going to observe that, you need to factor out this 4 on the inside so you can observe x by itself. So if you just look at x by itself before it gets multiplied by any other coefficient, it's x minus 2 inside there. So actually, this is just an absolute value graph that got shifted right 2, and 4 is just the slope of the line. If you remember anything about transformations, that 4 inside there, that changes like the slope, not only the slope of the lines, but also the width. That changes the width of the graph. So actually it makes the V skinnier. So in terms of transformations, this just is shifted right 2. So we can make this V shape shifted right 2. So instead of at 0, 0, I'll put a point over here at 2. And then from there, I'll make this V. But look, I already got these lines. Look, one of them's even got a y-intercept at 8. So I'll go put a point at 8, and then the slope's -4. So I can just go ahead and start with that piece. So that's the left side of the V, and the right side of the V. I'm going to put it at 2, 8. This point right here, 2, 8. Because I know the V is symmetric. So if you got this part down, and that one was over 2, then move over 2 more points, and at the same height, put a point. There's the V. Or if you want to just graph both lines by themselves, feel free. But now you know what the domain is for this piecewise function. So, how far do we want the negative one or the positive one? So how about 4x minus 8? Which piece is that? That should be the piece over here on the right. So if the 4x minus 8 is on the right, because that's the line with a positive slope, and if you looked at the y-intercept, if you drew that already, it goes down to negative 8. So I'll just add that. That's 4x minus 8. So those x values, looks like, would go from 2 to infinity. And then, so this other one, this must be the negative 4x plus 8, because the y-intercept's that high. So those x values would be from everything 2 and below. So for the domain, the negative 1 is x less than or equal to 2. So look at this line. When do you want this line to work? Well, from 2 and then everything less than that on the x-axis. 2 and then everything less than that. So that's the domain for that piece. And then, since 2 is included in the negative piece, let's say the positive piece gets everything from x greater than 2. Alright, that's all for these notes. See you in class.